Lesson 1.6, determine quadratic equations when you are given the roots. As a quick review, we know three forms of quadratic equations. We have quadratic equation in standard form, ax squared plus bx plus c. We have it in vertex form, a times x minus h squared plus k. We have it in factored form, a times x minus r times x minus s. Okay, these are the three forms that a quadratic equation can be in or can be put in. They are all helpful in different ways, okay? You notice they all have a coefficient a. That tells us the stretch, compression, reflection, okay? If a is greater than 1, it's going to be a stretch. If it's in between 1 and -1, it's going to be a compression. If it's a positive number, it's going to open up. If it's a negative number, this is going to be reflected over the x-axis. Those terms should be fairly familiar. If they're not, then keep reviewing. All of the forms give that information. The other things that I've written give information about the quadratic, about the graph of the quadratic without doing any math at all. Okay? This standard form gives the y-intercept constant. How do I know that? The y-intercept occurs when x is 0. Well, if x is 0, then this term is 0 and this term is 0, and my final answer is just the value of c, which is any constant. Okay, so standard form gives the y-intercept. Vertex form gives the vertex, right? The vertex is hk. What else does it give from the vertex? You determine the maximum or minimum value. That's going to be the y value of the vertex, which is right there. It gives you the axis of symmetry, which is the x-coordinate of the vertex. X equals h. It's right there. Gives you the vertical translation and the horizontal translation. That means how much did this vertex move up and down and how much has it moved left and right. That's what translation is. So if the vertex is not 0, 0, it's moved left and right or up and down. Factored form, which is what we're working with today, gives us the stretch, compression, reflection factor, which is right there. We're going to have to remember that to put an a into our equations. And it also gives us the zeros, okay? That means it gives us the roots of the equation or the x-intercepts of the graph. All of these words correspond to one another, okay? They basically all mean the same thing. Okay, what else do we need to know? In these notes, you can probably squeeze at the very top of 1.6. Possibly the bottom half of page 24, but it doesn't matter a lot where you put these. Actually, it's short. You can squeeze it at the top above the title. So we're talking about families of quadratic equations. Families of quadratic equations. You need this definition to kind of understand what's going on here. But a family, and you can do this with quadratics, you can do this with linear things, but the definitions are slightly different. A polynomial, it would have the same definition, okay? But a family of quadratic equations is all of the quadratic equations that share the same roots. All of the quadratic equations that share the same roots, and under roots you could put zeros, x-ints. What does that mean? Well, it's all of the quadratic equations that share the same x-intercepts, which means if you know the x-intercepts of an equation, let's say you know the roots, that's here and here, I'm just a random example, you could say that I'm going to draw a handful of equations, okay? This guy, I could do a real tall skinny one, upside down, okay? So far what I've drawn, they're all in the same family. We could draw a really fat wide one, okay? All of those graphs of quadratic equations are in the same family because they have the same roots. Are they the exact same equation? No, but they are the same family. They have the same roots. What would be different about them would be this stretch compression factor. Okay, so that's what we're doing today. Okay, example 1. Example 1, we are given the roots of a quadratic family, and we're going to find the equation in factored form for a family of quadratic functions with the given x-intercepts. Then we're going to sketch each family, showing at least 3 members of that family. How many members are there in a quadratic family? 6? 4? 2 members?
3 maybe?
Probably like unlimited.
Unlimited. Literally unlimited.
You are so
Infinite number. There is no limit to the number of quadratics you can draw, parabolas you can draw going through those 2 given points. You can make it any stretch compression ratio, upside down, whatever you want, as long as they go through those 2 points. It's infinite, okay? Good job. Here we go. Example 1, the first set that we're given has roots or x-intercepts at 4 and 2. Okay. Nope. Are they at 4 and 2 for you? No, 0 and -5. I switched those around. Okay. 0 and -5. What does that tell us? Remember, the roots correspond to the factors. So if I have a root of 0, that means subbing in 0 to my equation will make the whole thing 0. It's a little bit confusing. If I sub in -5 into my equation, the whole equation becomes 0. So that's why our roots tell us what our factors are. So if we're given the roots 0 and -5, then x, and you don't need to write this. I'm going to write another sentence for you. X and x plus 5 are the factors. Okay? Factors means 2 things that you multiply by each other to get a product. So x is a factor and x plus 5 is a factor. I'll make that make sense right now. So our function is f of x equals, I'm not done after this, but it's worth talking about at this point. So this is one member of the family. Okay? It has a factor of x because if I were to sub in 0, this factor would become 0, which makes the whole thing 0 because anything times 0 is 0. If I subbed in -5, this factor would become 0. Okay, this factor would then be -5, but this factor would be 0, and anything times 0 is 0. That's why we call them zeros. Okay? So this is one family, one member of the family. This does not represent the general equation for the family. Why? Because this just indicates the 2 x-intercepts, but I could have any stretch compression factor. So you need to put that a in front of the 2 factors that you have. Okay, if this is still a bit foggy, that's okay. We're going to do 3 more. It's going to make more sense, okay? And we'll draw the members of the family afterward. Okay? Actually, let's list our members. So this goes in the first box. This goes in your first box. Okay? Your next box has space for 3 members of the family. Okay? Which basically means that you can take x times x plus 5 and put in any value you want there for a. Okay? My recommendations when you're coming up with examples is not to make a 1 and then 2 and then 3. That's not helpful. Okay? What's helpful would be putting an example like f of x equals -3 times x plus 5. This is now a specific member of this family. Okay? Here's another one. Let's say g of x, and let's make it 1/4 times x plus 5. It has the same zeros, the same factors will give it the same zeros, but this one is stretched and upside down. This one is compressed. It's really fat and wide and right side up. Okay? Go ahead and come up with your own third example, and then we'll carry on. Okay, my third example was h of x equals 4.7 times x plus 5. Okay? It has the same roots, but it has a different stretch compression reflection. Okay? Let's go look at our next example. We are given the roots 4 and 2. Okay, if 4 is a root, then that means x equals 4 will make the function equal 0. Okay, if 4 is a root, then x minus 4 is a factor. And if 2 is a root, then x minus 2 is a factor. I know that because if I put 2 into my equation that I'm going to make, it will turn a factor into 0. So what is our equation going to be? Well, let's go with f of x equals, I know my two factors, x minus 4 and x minus 2, and I never want to forget that for the family of equations, a can be any value, so I have to put a in there. Back in grade 10 or 9, when they didn't have a stretch compression factor, you probably saw them like this, and that was good enough. But now we know how to stretch and compress them and flip them upside down, so we need to have that placeholder for a, okay? Okay, good. We have the family of quadratic equations. Now we need specific quadratic equations. What does that mean? Well, right now I could draw a whole bunch of quadratic relationships, a whole bunch of graphs of parabolas that go through 4 and 2. But now we want to write some specific members of this family. So again, you're writing any multiple for a, any value you want for a. Okay, I'm going to start with -1/2. And my factors need to remain the same because the roots need to be the same. I need this parabola that I've now made to actually go through 0, 4 and 0, 2. Okay? Go ahead and come up with a couple more.
So, why do we take away?
There are 2 more examples for this part, but let's split it and let's draw the graphs for this. Okay, so that's what one of yours looks like. The other one looks like this, 4 and 2.
No, it's on the other side. Yeah.
Backwards. Pardon?
No, the first one was
Yeah.
right.
My first one is actually wrong.
Oh.
So it should look like this,
That's not.
and it should look like this. If it doesn't look like that, then yours is wrong, but that's okay. If yours are opposite, then just draw an arrow to the opposite one. Okay, paying attention, please. In this first example 1a, the zeros are 0 and -5. What does that mean? Well, it means all of the members of this family go through 0, 0, and go through 1, 2, 3, 4, 5. -5. Okay? So go ahead and draw some members of the family. Maybe try to draw the ones that we wrote. Okay, I have g of x, which is 1/4 is the stretch compression factor. So that's a compression, a vertical compression by a factor of 4. Okay, so that's going to be really squished. Maybe something like that.
I have a question. How do you just draw that?
It's just an estimate. We don't know where the vertex is. We don't need to know.
But
Okay.
the equation is saying it's +5. It's +5, isn't it?
Nope, it's saying that it goes through, it has a 0 at -5. Because an x value of -5 will cause this factor to be 0.
Oh yeah, so we switch that.
0 times anything is 0. Okay? I'm going to draw my f of x, which is -3 was my stretch compression factor. So that might look something like this. It's upside down, and it's tall and skinny. Again, my pictures are not perfect. They don't need to be. And then I had another one. 4.7 was my stretch factor, and it's opening up. So that one's even taller and even skinnier. Maybe it looks something like this.
What would a stretch factor -7 look like?
That would be tall and skinny and opening down. Be upside down. Okay?
The higher the number, the skinnier it is.
Correct. Okay, so that's just 3 members of this family. Okay? Let's go to our next one. The zeros are at 4 and 2. Go ahead and draw those. 1, 2. 3, 4. Okay, there's our zeros. The members of the family that I had was negative 1/2 as a stretch compression, so it's going to open down, and it's going to be fatter than usual. Something like this. What about a stretch factor of 2? That's going to open up, and it's going to be twice as tall, twice as skinny as usual. Might look something like that. Again, we're just getting a general feel for these things. And then my last one is negative 10.4, which is upside down because it's negative. So it opens down, and it is very tall and skinny. I'm not even going to be able to fit it here. But it might look something like that. And I'll just imagine that it goes higher. Okay, you should be getting a feel for what the stretch compression factor does, but also the concept that if they have the same factors, that means they have the same roots, which means they have the same x-intercepts. And there's an infinite number of possible quadratic equations that go through those 2 points. Okay, I'm going to buzz through example 1C and D a little more quickly. Okay, question just came up. What happens if your stretch compression factor is 0? Well, what happens when A is 0? That would make the whole thing 0, which would mean that there is no, the answer is just y equals 0. It's just a line at y equals 0. It becomes a constant. It wipes out everything else that's going on. Does that make sense? So it means it would always be, if A is 0, then it doesn't matter what x is, the value of the function is always 0. So I draw a graph of that. There's my coordinates. Here's my line y equals 0. Horizontal line along the x-axis. Okay? If A is 0, then it doesn't matter what x is. The value of the function is always going to be 0. So that's what happens if A is 0. Another question came up, which was similar but worded differently. What happens if there is no stretch compression? Doesn't mean that A is 0. It means that A is 1.
Why 1?
Okay, if there's no stretch compression, you're just left with this. And A is 1 because anything times 1 is itself. So only the number 1 as a multiplier will do nothing to the quadratic equation, in which case it will have the same shape as y equals x squared, standard parabola, but it will be moved side to side. Okay, and it will always open up. If you just had a negative sign there, it would be the same shape as x squared, but it would open down. Okay, so 1 is the multiplier that doesn't change it. 0 would change it significantly. 0 would wipe out the whole thing and make it a linear equation at y equals 0.
What would 1?
So what would it look like if this stretch compression factor was 1? In which case you wouldn't even see it in the equation. Okay, because you don't need to write a factor of 1 because 1 times anything is just itself. It would just be y equals x squared, which is a standard shaped parabola that goes through the origin at 0, 0. Anything else, all it does is change the size and shape of this or move it around, but it's still a parabola. But this is called the parent function. This is the parent function for quadratic relationships. Okay, in part C, we have two x-intercepts. They are 3 and negative 3, which means our factors are, try and write down the factors. So if 3 is a value of x that would make the whole thing 0, then x minus 3 must be a factor. And if negative 3 makes the whole thing equal 0, then x plus 3 must be a factor. Because x equals negative 3 would make that factor 0, which would make the whole thing 0. Good. Here's the family. Now for some specifics. I'm just going to do 1 because I'm getting tired of this example. Negative 1/3 x minus 3 x plus 3. Try to write down a different one than me. Don't write down a negative 1/3. Try to think of your own.
Too late.
Then do 2. Okay.
Okay,
Those are
just-
positive ones. Right?
D is a key example, so please pay attention. It says that the only factor is, the only root, sorry, is 6.
So it's
Okay.
just a straight line.
Note, remember a root is a value of x that causes the equation to be 0, that causes the value of the function to be 0, but it's still a quadratic. It's still a quadratic. So if 6 is the only root, and there still needs to be 2 factors, turns out that it causes a double factor. So what is the factor that has a root of 6? We can agree with that?
Yes.
But it still needs to be a quadratic. So it turns out that you have this factor twice. You have this factor twice. Okay?
Right.
What does that mean for your drawing? Well, it means it's going to touch the x-axis at 6 and then bounce back up. Or touch it and bounce back down
Oh,
if
so
it's upside
just
down.
gonna have one,
So it's only going to touch it once,
what's that called?
which is what
Only
we talked about.
one-
Is that the
It just
rad?
means there's one solution.
One solution.
The only solution is 6.
It just goes.
Okay?
It's a J.
So what am I missing here in this parent function?
You're missing something for
You're
In the
missing the
family?
A.
I'm missing the stretch compression factor. Go ahead and include one member of the family in the box below.
What do you mean you include a member of the family?
like,
Oh.
Change the value of A to a specific value. Okay, and you could draw these things. I'm just going to do it kind of quickly. Okay, for the one on the left, example C, it goes through -3 and +3. Those are our zeros. So any quadratic, any parabola that goes through those 2 points is good. Okay? I'm drawing a whole bunch. And I'm going to move over to D. It touches at 1, 2, 3, 4, 5, 6. So any quadratic that touches the x-axis at x equals 6 is a part of the family. So it might be fat and upside down. It might be skinny and upside down. It might be skinny and right side up. It might be super duper duper fat and right side up. As long as it touches, as long as it has the same root, as long as it touches the x-axis at x equals 6, it's a part of the family.
I have a question.
Example 2, determine the exact equation of a quadratic function. Okay, so we know how to get the family, and we know that all we need in order to get the exact member is to change the letter A. Okay, but this time we don't get to change it to whatever we want. We have to change it to the one that creates the parabola that they want us to create. So we're going to start where we were. In A, it tells us that our zeros are 2 and 2. It also tells us that it goes through the point 0, 3. What does it mean if a curve goes through a point? That it satisfies the equation. Boom. Okay, good.
So
So-
second 2 is a negative, by the way.
Good call.
Oh,
One
mistake.
Yeah. Okay, so the family then, paying attention, the family, you already know how to do this, so I'm not going to do it slowly.
No.
There's the family of equations. Now, how do we create the equation that goes through 0, 3? So we said the point 0, 3 satisfies the equation. Well, the point 0, 3 is x, y. So this is an ordered pair, just like you've talked about at the beginning of this unit, that satisfies the equation. That means if I put 0 in for x and I put 3 in for y, I need to find the value of a that makes the statement true. Okay? So f of x, the value of the function, corresponds to y, okay, is 3. A, I don't know yet, but I know that if I substitute 0 in for x in both places, because x can't be the different value in the same problem, okay? It's always the same value within that problem.
So you only use. Never mind.
It's okay. So now I am solving for a, because a is the only missing value left. So I'm finding the A that makes this statement true. How do I do that? Well, A, this bracket reduces 0 minus 2 is negative 2. 0 plus 2 is positive 2, which gives me A times negative 2 times 2. Well, that's negative 4. Negative 4 times A. I can write that like this. Now to get A by itself, I'm going to divide both sides by negative 4. I'm also at the same time going to put A on the left. Maybe I won't, just for your sake, but I'm going to divide both sides by negative 4. That gives me negative 3/4 equals A. So a question comes up, why do we substitute 3 for x? But we didn't actually substitute 3 for x, we substituted 3 for f of x. Okay? This is the same as y equals yada, 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 yada. So in function world, in function notation, x, y, that ordered pair is the same as x, f of x. Which means when you sub in x, this is the value of the function. Just like here, when you sub in x, this is the value of y. Same thing, okay? Okay, so A is negative 3/4, which tells us that the exact member of this family that goes through 0, 3 is f of x equals negative 3/4, and our factors are x minus 2, x plus 2. So now it still has zeros of 2 and negative 2, but it has a stretch compression factor of negative 3/4, which causes it to go through the point 0, 3. There is no other member of the family that will go through 0, 3. The only member of this family that goes through the point 0, 3 has a compression factor of 4/3 negative, and it's reflected over the x-axis. Okay, this is the only one that will go through 0, 3. Second one, B. B says we have a double zero at x equals negative 2, and it says containing the point, or goes through the point, 3, 10. Okay, what does a double zero mean?
X 0, 0.
0, 0.
It
Or
means
zeros.
there are two factors of x plus 2. So if a 0 is x equals negative 2, that means the value of x equals negative 2 will cause the value of the function to be 0. So one of the factors, we know there's an a out front. The factor is x plus 2, but it's a double zero,
So you got a square?
which means it's two of those factors.
That's mine.
And we know that the point 3, 10 does what?
You sub it in.
Satisfies the
So
equation.
put the 10 in the
All
end.
right, so 10 is here for y,
Shh, don't shush me.
and 3 gets subbed in everywhere we see x. And now a is the only thing unknown, and our goal is to find out what a is so that the statement is true. All right? On the left, we can leave 10 for now. On the right, we have a times what? We've got 5 squared. Yeah, I'll do it in 2 steps. 5 squared. That gives me 10 equals 25a. Here's one big mistake that people often make. They say, oh, 25 is bigger than 10, so a is probably 10 over 25. Or you mix it up, or you say 25 is bigger than 10, so a must be 25 over 10, 2.5. That's wrong. Okay?
Divide.
You have to divide both sides by what? By 25. So you have 10 over 25 equals a.
Is that because 25 is attached to A?
Should we
Correct.
reduce it?
Ah.
25 is attached to a by multiplication, so to undo that, you have to divide both sides by 25.
Yeah, I said we could.
That gives us the specific member of the family.
Should we not reduce it?
Yep, you could reduce it. So you could divide both by 2/5. So we have an a of 2/5 times x plus 2 squared. Okay, you're just subbing your value of a that you now know into the equation for the family of quadratics that has a double zero at negative 2.
Why is it?
The next one's a little bit more challenging, so make sure you have enough space and be careful, okay? This time, the zeros that were given are kind of awkward looking. They have radicals in their expression. Okay? So we have 3 plus radical 5, and we have 3 minus radical 5. Okay? And we're going to go through the point through to negative 12. Now, we do this the exact same way as we have. Okay, we set it up the same way. We're given the function. We have a constant multiplier out here, a factor of a. And now inside these brackets is still x minus r, x minus s. So x minus one of our zeros, which is 3 plus radical 5. Okay, why did I double bracket it? Why did I put it in brackets?
Here, it's a separate one altogether. Like 3
You
plus
have to
negative
deal
is
with that equation separately.
It's a group, and this negative sign applies to both terms inside that group. Okay, my next factor is x minus s, which is x minus, and my other 0 is 3 minus radical 5. Close, close. So now I still have 2 factors and an a. Can you see that? I have a, I have a factor here, and a factor here. Okay? Now, this one, when we expand, okay, we're going to expand this 0, this negative sign to both terms, and this negative sign to both terms, and then we're going to see how that changes things, and hopefully you start to see a bit of a pattern emerging. But here we go. We've got f of x equals a, and inside this bracket, we're going to have x minus 3 minus radical 5. Okay, that's how I break down that bracket. In our second factor, we've got x minus 3, but now I have this negative times a negative, which is a positive radical 5. Okay, you have to do these ones carefully. You will get this on a test, and you just need to do a handful of the practice problems. Well, now I actually see something that wasn't there before so obviously. Look at what I created. X minus 3 here, and x minus 3 here. Okay, now look at what did we create? This is the product of a sum and a difference. Do you remember that?
No.
totally
This
solid.
is the product of a sum and a difference. Dot, dot, dot. What can the product of a sum and a difference be reduced to?
A minus b squared.
That's really close.
Oh!
A squared minus b squared. Yeah.
Oh.
This, it reduces to, do you know what that's called?
Probably.
A difference of
Squares.
squares. Okay, Mr. V, slight translation here. If you have a minus b times a plus b, it equals a squared minus b squared. Okay, if you don't understand that, that's okay. You can think about it later. For now, I'm just going to finish out this problem. F of x equals a. And then here, now I have a minus b times a plus b. Here's a minus b and a plus b. If all those extra notes are kind of bugging out your eyes, don't write them. Okay? So a is x minus 3. So what do I have? I have x minus 3 squared minus b, which is radical 5. So radical 5 squared. Okay, so we just took our difference of squares. We took our product of a sum and difference and made it into a difference of squares. Why do we do that? Well, because now it can be reduced into something we actually understand. Here, x minus 3 squared, we dealt with these the other day. the expansion of x minus 3 squared is x squared minus 6x plus 9. Okay, if you can't do it that quick, that's okay. This is a squared binomial, and this is its perfect square trinomial. Basically, I've doubled this thing, expanded it, FOILed it, all in one step. Okay?
Oh, that's quick.
And square root of 5 squared. If you have the square root of something and you square it, you're just doing something and undoing something, so you're left with 5. So this is minus 5. We can group like terms. We have a x squared minus 6x plus 4. Now all we've done so far is reduced or gotten the general equation for this family. So this is now the family of this quadratic, given in simplest terms. But now what do we still need to do to find out the exact equation that goes through to negative 12?
Add to them.
We need to sub in 2 everywhere we see x. And we need to sub in negative 12 everywhere we see y, or f of x. That's the value of the function when x equals 2. Now the only variable left is a, so we can solve for a. 2 squared is 4. 6 times 2 is 12. Yep. That gives me negative 12 equals a times negative 4. That means a is negative 12 divided by negative 4, which is positive 3. Therefore, the equation of the function that goes through, that has zeros at these funny zeros that they gave us, and goes through the point 2, negative 12, is f of x equals 3 times, and now I'm just looking up to here for the place where I have the family of equations, but I know a is 3 now. X squared minus 6x plus 4. You could give that in a different, slightly different form. You could multiply every term by 3, and you'd get 3x squared minus 18x plus 12. It's the exact same quadratic. In example 3, we're going to use a quadratic function to represent given information. So we have a parabolic opening to a tunnel that is 32 meters wide. So if I draw a sketch of that, parabolic tunnel opening, 32 meters wide, measured from side to side along the ground. At the points that are 4 meters from each side, the tunnel entrance is 6 meters high. So if I backtrack 4 meters here, we'll be at a height of 6 meters. And if I draw 4 meters in here, again, we'll be at a height of 6 meters. Now that shouldn't be so surprising because parabolas are symmetrical. All right, we sketched a diagram of the given information, and to do even better job on this diagram, we should put this on a coordinate plane. So what I would do is I would say, here's our height measurement, which is our y-axis, and here is our ground level, which will be our x-axis. And now we have some even more specific information about the graph itself. If we know it's 32 meters wide and that it's symmetrical about the y-axis, then we know this is 16, an x value of 16, and this is an x value of negative 16, which tells us that this point right here, 4 meters back, is an x value of negative 12. Right here we have a value of positive 12, which also gives us the coordinates of these 2 points. We may as well add them. We're going to need one of them. X is 12 when y is 6. X is 12 when y is 6. So here we have a pretty good drawing of the situation that we have. This is the tunnel that we're driving through. The point 12.6 comes from the information when we go back 4 meters from the wall. We're 6 meters tall. And we could add the point -12, +6 as well, but we don't need to. B says determine the equation of the function that models the opening of the tunnel. Well, we're getting back into what we know about our zeros. If we have the roots of the equation, then we can develop a family of equations, which means we can get the specific equation if we have one of the points. So first thing we're going to do is look at the x-intercepts. What are the x-intercepts?
-12 and 12.
Why'd you get
Oh,
12 and
6,
6? Mr. Reed?
-16 and 6.
Okay, -16 and +16.
How'd you get?
From our two x-intercepts, we can get our factors within the family here. So we're going to call this f of x, which is the height of the tunnel with respect to the width, or the distance from the center. And if our zeros are -16 and +16, then what are our factors?
16 and -16.
X plus 16 is a factor, and x minus 16 is a factor. I have this multiplier a out there. That's to indicate your stretch compression factor, which is unknown at this point. This is the family of quadratic equations that have their zeros at 16 and -16. But we need a specific member of the family. We need the member of the family that we drew here in the tunnel. So we need this. We need to know the value of a. Well, thankfully, they gave us a point that satisfies the equation. A point on the curve is a set of coordinates that satisfies the equation. So if I sub in a y value of 6, which is f of x, and an x value of 12, everywhere I see 12, I just plug in, everywhere we see x, we just sub in 12. And now the only variable left is a, and I can solve this. Left side is still 6. Here we have a times 28 times -4, which gives us 6 equals a times -112. And again, here we need to remember we're dividing both sides by -112. Okay, so we end up with a equals 6 over 112, and it is negative.
Wait, sorry, you're dividing each side by 6, or?
Dividing each side, I have a times this. In order to get a by itself, I have to undo the multiplication by this, which means I have to divide by this. So divide both sides by that. Do not put 112 divided by 6 just because 112 is bigger. Please follow the rules.
-112 or just 112?
What does it say?
It becomes negative.
Okay, so now we can simplify that. That reduces to -3 over 56. Okay, we're not going to make that a decimal. We want it as exact as possible. This tells us then that the function that models the tunnel is f of x equals -3 over 56 times x plus 16 times x minus 16. This is B. Okay? B. A was to draw. Good. C says find the maximum height of the tunnel to the nearest tenth of a meter. So the maximum height of the tunnel. There's a couple of things that we could do here. Maximum height occurs at the vertex, right? So we could convert into vertex form. Does that seem reasonable?
Yeah, no. Yeah.
Does that sound fun? Like you want to do that right now?
No,
don't want
no,
to.
that's my
Okay.
vertex.
Well, we already actually know where does the maximum happen. What's the x value of the vertex? 0. Okay, the x value is 0. So we know that the maximum height is going to be the value of the function when x equals 0, because this point right here is 0 something. So really all we need to do for C is sub 0 in for x.
Boom.
In this case. In other cases, you might, if this parabola is not centered around the y-axis, you would probably need to convert to vertex form, or you could just take the middle of your two x-intercepts. You could do partial factoring. That would work as well. But here we go. I can when I'm done. So we're going to sub in 0 everywhere we see x. The rest of it just stays the same.
What formula do you use to put it in vertex form again?
We can talk about that in a second. This reduces our brackets, so we still have negative 3 over 56. Then we have positive 16, negative 16, and that's all going to get multiplied together. So on your calculator, you would go with 16 times 3. Two negative factors means it's going to be positive, and then you'd maybe hit enter, or you just hit divide by 56. And your calculator would check out. And go ahead and check it on your calculator to see how we did, please. Should get approximately 13.71, which means, therefore,
Yes.
the max height of the tunnel is about 13.7 meters. Max height of the tunnel is about 13.7 meters. Okay, what did we do? We did a quick sketch. If you ever get a word problem and you're not sure where to start, just draw it. If you're not sure how to draw it, I actually started by drawing my parabolic arch. I drew the tunnel first and I added all my lines later based on the information that I saw. Okay? Then we got the family of quadratic equations from our roots of negative 16, positive 16. Once we did that, they had given us information about 2 other points on the curve. We knew this point as well, but we didn't need it. You only need 1 point that satisfies the curve to find the unique equation that would model this exact parabolic arch. And once we did that, they asked us to find the maximum height. And in our case, the maximum height occurred at x equals 0. So if I need to find the value at x equals 0, I just sub 0 into the equation everywhere I see an x. Solve it out. 13.7 meters high.
Nice.